my topic was Arctic amplification in Tuktoyaktuk, and that is a community, well not community, but it's a city in Canada, Northwest Territory in that area. And I was under the mentorship of Ruth Moore from the University of British Columbia. Um, so for this presentation, I'm just going to be just talking a little bit about me so you get to know who I am. And then I'm going to go into why I picked the Arctic as my area of research. And then I'll just actually talk about my research, and then I'll go into my Talaria experience. So about me, I am a senior in high school this year. In college, I went to major in environmental studies. That's probably why I picked this topic. Also, I really love music. I play a few instruments, and I enjoy singing. And I also love watching Netflix in my free time. I guess the most recent show I finished was Never Have I Ever, season 3. So I don't know if any of you guys have watched it, but it was an interesting show. So yeah, it's just a little bit more about me. Um, so yeah, why is studying the Arctic so important? So, well, the first reason I picked studying the Arctic was because it was like my mentor's research area. So that's what she knew the most about. She focused on the Northwest Territories and specifically climate change in the Northwest Territories of the Arctic. And I kind of got pulled into it more as she explained like the significance of climate change happening in the Arctic, because the Arctic is warming 3 times faster than the global average, so way faster than the rest of the world. And this has major effects on the Arctic ecosystems and indigenous communities. And sorry, my screen is glitching. Give me 1 second. Okay. So I was like drawn into this topic because social justice is something that's like really important to me. So when I saw how much the indigenous communities in Arctic were being affected, I kind of was like, I want to really learn more about this, because there are like some people that have some of the least agency in the Arctic, and it just kind of sucks because they do a lot for the Arctic. Like they hunt and they fish there, live there, they support its economy, yet they really aren't receiving much attention from the government. So yeah, that's really what drew me into this topic. Okay, so introduction to get started on my research. If you don't know what Arctic amplification is, since I mentioned it in the beginning of this presentation, it's a positive feedback loop and it's triggered by the greenhouse gas effect, which is essentially when greenhouse gases are released and they trap heat in the Earth's atmosphere and they cause global warming. And that is causing the Arctic to warm faster than other parts of the world. Just to give you guys a little statistic, between 1948 and 2016, the amount of warming that occurred in like throughout whole Canada is 1.7 Celsius, but in north of Canada specifically, it was 2.3 degrees Celsius. So specifically, the area like I mentioned before that my mentor is studying is Tuktoyaktuk. That's right here. And to explain what a positive feedback loop is, if you don't already know, that is when like the product of a reaction stimulates it more. So in this case, Arctic amplification is being stimulated by permafrost thaw and sea ice melt. And I'll start with sea ice melt here. This is a graphic showing how there are receding ice lines in the Arctic. So the more that this ice is melting, the more it's going to trigger warming, because there's something called albedo, which is essentially the reflectivity of the surface. And when there's less ice, it means there's more water, obviously. And the more water means that the water is going to have a lower albedo and reflect. It's going to reflect less heat. It's going to absorb more of it, and that's going to cause more warming in the Arctic. So that's one factor that is, keeping Arctic amplification going. And another one is permafrost thaw, of course. So when permafrost thaws, permafrost contains huge amounts of carbon and like other greenhouse gases, but primarily carbon. And when it thaws, as you can see in this graphic, that the carbon gets released into the atmosphere, and that adds more greenhouse gases, and continues greenhouse gas effect, continuing amplification. And so, just to talk about some of the effects of this and why it's having some implications on the indigenous community. As you can see in this graphic, this is showing a retrogressive thaw slump, which is what happens when permafrost thaws so much that the whole ground comes like soft and squishy, I guess, and it just collapses. And you can see the parts of it. I won't go into it that much. It's not really that significant for this presentation. Yeah, and I just wanted to show you guys this visual that is showing what can happen after this permafrost thaws completely. Some parts can completely break off the coast of the Arctic, and this is called coastal erosion. And it's important to note that this permafrost contains microbes, like microorganisms, metals, nutrients, and dead plant matter, which I mentioned before contains a lot of carbon, specifically 1.5 million tons of it, which is a lot. So yeah, I hope this visual gives you guys more of like an understanding of how bad the situation was. And let me go back for a second. So this can also have an effect on aquatic ecosystems in the Arctic because a lot of the nutrients and microbes getting released into the water are stimulating the growth of phytoplankton. And so I wanted to show you guys the Arctic food web so you can get more of an idea of how it works. So you start here with your phytoplankton, and the nutrients getting released from the permafrost are stimulating their growth because they it helps them grow and stuff. But then you have the zooplankton, and that's what I really focus on in my research. The zooplankton, they are very important for Arctic ecosystems because they're at the middle. So they eat the phytoplankton and everything else eats them for the most part. So if something happens to them, then the whole food web is toast, essentially. So that's why zooplankton is very important, and why the effects that Arctic amplification has on them is really important to study. So let me go back for a second. And everything that happens, as I just explained with the food web, this also has an effect on indigenous people because they eat a lot of these aquatic animals. And we go back like here, you can see this is a seal that Inuit hunters. Inuit are the indigenous people specifically. That's what they're called. In the Northwest Territories, they like to hunt a lot, and so if something happens with this food web, then their food supply is in trouble too. So I just wanted to find my research a way to just directly show that this permafrost thaw is leading to changes in like the aquatic ecosystems, and then I wanted to see how it was directly affecting people living there. So for my methods, weather was really important because Arctic amplification involves a lot of like changes in temperature and precipitation. So what I did was I used Python, and I had to learn to use Python, and I used data from Tuktoyaktuk on the Canadian government website, and it showed me like the temperatures of like since like 1950, the precipitation, the rain and snow, and this went all the way up to present day. And then that was for evaluating the weather, but then for evaluating the effects of permafrost change and water quality, I use mostly Google Scholar as my search engine, and then other electronic databases like PubMed, ResearchGate, and the Wiley Online Library. And then I also used some news websites because I found that they're a lot easier to understand, and it really gave me more of an idea of what's happening currently in Tuktoyaktuk. So we can go on. For my results, starting with the evaluation of data, I graphed this right here, and this is showing the daily temperature trend in Tuktoyaktuk since 1950 to present day, and you can see it's going up and down because as seasons happen, the temperature changes. So this is just plotting the temperature every day, but then that wasn't really significant enough data to find a trend or like draw any like conclusions from that. So I then plotted the yearly mean temperature. So I found the mean temperature for each year, and that's in these dots, and I found the minus plus fit, which is a slope, and you can see that there is a 3.5% slope, meaning that the is a 3.5 increase in yearly mean temperature, and that is very significant. The temperature is like getting hotter each year, and 3.5% is a lot. So that is something that I really paid attention to. It was something that stuck out to me because it really just gave me an idea of just how much the Arctic is warming. And then I also evaluated the precipitation happening in the Arctic. I used this graph right here, I plotted, which is showing how the precipitation trend is daily. You can see it's a lot less consistent than the temperature trend. It's very sporadic. On some days it doesn't rain at all in the Arctic. So it was very hard to draw conclusions from this data as well. And as you can see, there are gaps in the 1950s, 1990s, and late 2010s. So that was like one big obstacle of my research, just trying to draw conclusions from data that wasn't there, of course. So to like find more of a significant conclusion from that, I plotted the yearly average precipitation. And so instead of like just like taking all this data, I found the just one figure for like each year. So this is the mean precipitation for that year, and then I found a line of best fit, and there was only a 0.1% increase, which is significantly less than the increase there was for temperature, but it's still enough to warrant attention. It's showing that there's a lot more precipitation happening that is coming along with this temperature increase. So that was something that I kept in mind. And so now that I knew that there was more temperature increase, more precipitation increase, I looked at how this, that's out of order. I looked at how this was affecting permafrost, and I looked at a lot of studies and experiments that were trying to see how frequent these slump events that I mentioned earlier were happening due to the increase of precipitation and temperature. And many of the studies that I reviewed showed that there was going to be a predicted increase in these slump events because they need enough precipitation to continue being active, because the precipitation is creating this erosion, which is going to be leading downhill, and it continues. So there's no precipitation. Obviously, these slumps are not going to get worse, but because there is more precipitation, they're going to get much bigger, and then these mini slumps are going to be turning into mega slumps, and that is bad for people living there, obviously, because that means that the ground is essentially breaking apart. And then another study that I reviewed, they were trying to see how much carbon specifically is going to be released from these slump events, and they simulated the carbon release from a lab, and they took field data too. And from that study, they saw that there would be like a 0.8% of the dissolved carbon from the permafrost that would actually be released and turned to carbon dioxide. So that is a lot of carbon dioxide that is entering the atmosphere from this melted permafrost. Go back. Now that I figured that, I had to evaluate the water quality, because this permafrost, like I mentioned before, is melting into the lakes and ponds, and so I had to find how this would be affecting the aquatic ecosystems. And as I mentioned before, zooplankton, that is really what I want to focus on, because they are an important part of the Arctic. I'm sorry, the Arctic food web. And so I analyzed certain factors for zooplankton, specifically the total abundance, the gender diversity, and the species eating this. I didn't create this graph, but I looked at a study that did analyze these three factors. They wanted to see how certain water chemistry variables would affect the zooplankton abundance, the diversity, which is just is there like a variable amount of species, and then evenness, is there more one species than the other type of species. And they saw that conductivity, turbidity, ion concentrations, and nutrient levels had the biggest effect on zooplankton abundance, diversity, and evenness. And this is a big deal because zooplankton, they found that in their study that zooplankton abundance was growing, but the diversity and evenness was decreasing. And if the diversity and evenness is decreasing, that means that there is more likely for zooplankton to not be as nutritious to other higher organisms on the food web, like the seals and the whales that eat them. So more zooplankton is not a good thing, and this is a cause directly of the melting permafrost, because the nutrient levels that are being released, it starts off with the phytoplankton, and zooplankton eat phytoplankton. So if these phytoplankton are not getting, the right nutrients that they need, they're just growing in number, but it's not essentially the right kind of nutrients, then that is going to affect the zooplankton, as I mentioned, going to affect higher trophic levels, including us humans, because we eat these aquatic animals too. And another study that I reviewed, it looked at the drinking water systems. It was a Nunavut drinking water system that is just another city in the Northwest Territories of Canada. And it showed that there was a lot of bacteria found in these drinking water systems. It took samples from different points of the drinking water system, including the tap, the pump house, the tank. So yeah, and they found that there was Mycobacterium, Legionella, and Cyanobacteria, and these specific Mycobacterium has a risk of what's called producing a lot of like lung illness, as well as Legionella. They both when inhaled or like digested, they can create a lot of lung illness for the indigenous people. And cyanobacteria is known to release toxins. Specifically in this drinking water system, there were not any cyanobacteria that were found to create toxins, but there are some like specific species of cyanobacteria that can. So that was important to note, that there are a lot of bacteria in the drinking water in these ponds and lakes for indigenous people that will be a risk to their health. So yeah, that was what I took away from the water quality, that it is becoming significantly worse than it was before, when climate change wasn't such a big thing. And then to wrap it all up, the effect on indigenous people is that they're going to have health issues. As I just mentioned, drinking water is becoming way worse quality. It's going to affect the gastrointestinal systems and their lungs too. And ground instability that is coming from the permafrost thaw. There is going to be a lot of collapses, which puts people who live on the coastlines, as you can see in this photo, at risk. In this photo of this resident of Tuktoyaktuk had to use lumber to try to prevent the water from overtaking their home. And that also comes with the increase of extreme weather events. There's more precipitation, more flooding, more cyclones. All of that is going to make it harder to live in Tuktoyaktuk. Ground instability, as I mentioned before, not only affecting the people that live there and their housing, but also making it harder to hunt, making those roads unsafer, especially for shipping too. Like the trucks that come on the permafrost ground, it would be unsafe for them too. And then food insecurity coming from the organisms that are now going to be affected by zooplankton. The species makeup is changing, so the organisms like seals, walruses, whales, they are going to be at risk too. They might disappear, and they're one of the main food sources for indigenous people. So that means that they might face food insecurity in the coming years and reduce income because they rely on hunting to make their money and support their economy. So in conclusion, I know that was a lot of information, but just to sum it up, we analyzed temperature and precipitations in Tuktoyaktuk. We saw how that was leading to permafrost degradation and how that is changing the water quality, making it worse, and leading to food web changes in Arctic aquatic ecosystems. In the end of it all, indigenous people are suffering because of Arctic amplification. So what's next? My mentor said that if I want to do future research on the project, or anybody want to do future research, that you could look into how the number of precipitation events is specifically affecting permafrost thaw, because like you mentioned before, there was a lot of gaps in the data. So if we would get, I guess, more reliable data, I mean, this data is reliable, but more conclusive data, we would see if the number of precipitation events, if there's more or less of that, how that is affecting permafrost thaw specifically, since we we didn't get to look too much into that because of the lack of data. So my career journey, overall, it was a very great experience. Week one, I learned how to use Python, which was very fun. I hadn't used Python like ever, I don't think. And so I got to learn how to code and everything like that. It's definitely something I'm going to be using in the future. And it was very hard. That was an obstacle for me. Some of the stuff I just didn't understand how to do. And it was just like, I don't know if I'm gonna be able to do this and like make these graphs, but like my mentor was very patient with me and to show me like you have to be like you have to look very close in Python to like see little errors because that will like change everything if you're trying to make a certain graph or like a certain visual. Week two, I actually created these graphs that I was talking about, the graphs you saw in these presentations with the Tuktoyaktuk weather data. And then week three, I finally started finding my sources, a lot of literature reviews, studies, experiments. I just kind of compiled a list of them, started reading them, and I created a mini presentation. And it was kind of like a one-slide version of this whole thing to present to my mentor and two other of the colleagues and the two other mentees. It was kind of like a practice thing, and it really helped me, I guess, become more comfortable with presenting, I guess, scientific presentations because I never really had to do anything like this unless it's like science fair or something. And then week four, I finally wrote my paper, which I think that wasn't the hardest part, but it was definitely a very hard part of it because I hadn't written anything like this long in a while. And you have to really be specific with what you're saying. You have to make sure you're clear because there's going to be people reading this, of course. So that was a little hard for me, but I overall enjoyed it. I guess my favorite part of this whole thing was like learning Python and I think doing the actual research because I didn't do much research before my Talaria experience, but then I got to conduct a lot more research and I'm like, this is definitely something might want to do in the future. Maybe not full time, but like maybe in my free time. And yeah, my mentor, I wanted to give a big thanks to her because she was really supportive throughout the whole experience. She was patient with me when I was struggling and stuff like that, and she was always very lenient with her time. She met with me even if it was something really little that I just wanted to talk about, which I really appreciated. And so yeah, big thanks to her for supporting me through this whole journey and the Talaria program for giving me this opportunity to conduct this research that I probably would not have done this summer. So yeah,